real basic values. For example, what is 2 to the first power? What is 2 squared? 2 cubed? 2 to the fourth? 2 to the fifth? 2 to the sixth?
64.
Okay. Okay. What's 2 to the 0?
1.
Good. You remember that.
Wait, why?
Anything to the 0 power is always 1. Anything and anything. Whoa, what's going on, my friend? I don't know.
Hey, that's Petrov.
Is there a calculator?
Hi, Petrov.
Hey, Petrov, come on in! Is there a calculator? I'll see one, buddy.
I think Katie took it.
Katie probably took it.
All right, well, I'm supposed to give this to you from Mr. Nick.
Thanks.
Do you have AP?
I'm going to put it on my cardboard.
It's an eyeball.
It is here, very good. So we have 2 to the 0 was 1, and one of the rules in exponents is that no matter what, anytime you raise anything to the 0 power, it's always going to be 1. Sir?
Is it basically just because you divide it by itself?
Yes, and that's exactly what it is. Because we start looking at it using positive exponents. This is 2 times 1, this is 2 times 2 twice, 2 times 2 times 2, 2 times, and so on and so on. So if you don't multiply it by anything, you're kind of dividing the entire stuff. And then that means if you go backwards, what do you get then? Half. Very good. 2 to the negative 1 is 1/2. What about 2 to the negative 2? 1/4. Good.
Then 1/8.
Yeah, exactly.
Awesome. That's sweet.
So what's happening here is Petrov went, oh crap.
He's like,
He's hyperventilating. Somebody clear some air.
You guys are going really fast, but okay.
What's happening here is that you get some exponent rules. If you look at your calculator, you have on your calculator an inverse button.
I know that button. I never use it. Actually, that's the one. I do use that for physics.
Yeah, you guys use it a lot in there. What happens is you can raise anything. If I just type in 2 to the negative 1, there's that x to the negative 1 button. It means inverse. The inverse of 2 is 1/2. And obviously, it's going to put out a decimal. With any of these things,
Part of this interruption, the freshmen, visitors from NIU are returning, and they will be entering their 12th period class.
So what we use these negative exponents is, from what I understand when we're going through properties, you guys learned it a certain way. But what I like to do when I'm working with properties of exponents is to use a base 2. You guys know what I'm talking about when I say base 2? Okay. You're right, a binary is base 2, it's 0s and 1s. But when I'm looking at it in terms of the base 2, which one of those is the base? The 2. So 2 is the base, 3 is the exponent. So when I'm talking about when we're using base 2, which you're right, it's binary, it's 0s and 1s, what I like to use the 2's with is to show the properties of exponents. For example, if I take 2 cubed and I want to multiply it by 2 squared, think about your order of operations. Order of operations are, please excuse my dear Aunt Sally. Okay? So your good old-fashioned PEMDAS. What comes first?
Parentheses.
Are there any parentheses? No, but what are there? Exponents. So that tells me I have to take care of my exponents first. So, 2 cubed. And 2 squared? 4. What's 8 times 4? And notice, it is, dun dun dun! 2 to the 5th is also 2.
yay! Sarah did a really weird way.
She's something. Wait, what?
Why wouldn't it be like 4 to the 6th?
Ah, there's a reason.
Because you're multiplying, not adding.
Because what's happening here is, I want you to think of this as, what does 2 cubed in just plain blood and guts mean? 2 cubed is 2 times 2 times 2. What's 2 squared? Did you see any 6s in there? See any 6s? It is nifty. It is. Now, what do you got?
Is it just a coincidence that the first exponent was 3, second was 2, answer is 33?
Yes.
Okay, what would be the first exponent plus the second exponent?
Correct. That's exactly what it is.
No, what would it be?
3 plus 2?
No, like 2 cubed plus 2 squared.
Oh, then that would be 12. Because what's 8 plus 4?
She's asking if there's properties.
Oh, there is no properties of addition between this. This is only working for
Okay, so it would
multiplication.
be like 4 to the fifth.
What about this? No, it's a great question. 2 squared to the 4th.
Wow.
2 to the 8, right?
Correct, because why?
Because
You're multiplying by an exponent.
Because your parentheses tells you to go through and take care of the inside parentheses first, which would be 2 squared is 4. And if I do 4 to the 4th, well, 4 to the 4th is, well, let's see here. What's 4 squared?
16.
And then what's 16 times 16?
36 or 16.
Now, what is 2 times 4? Do you guys have, do you know where that caret button is in your calculator?
Yeah.
Yeah. The caret button's right above your division sign.
Wow.
Yeah.
It all works
So
out.
we don't have two of the 2 segments first, we can just do 1 5 and 2.
Exactly. And that's one of the things we're talking about. We have all these different properties that we're going to be doing. All this, I'm just leaving the world, probably easier. We have all these different properties we're going to work with, and there's about 6 or 7 of them. The first ones that we've looked at now are multiplication rules. If you have the same base, and you're multiplying together with different exponents, where a is the base, m or n is your exponent, all you're doing when you multiply those two values together is you take the base, a, and add the exponents. Like we did a second ago, we had 2 to the 3rd times 2 squared. We had 2 to the 5th, we wound up equaling 32. You add your exponents. The one we talked about a second ago, when you had, was it 2 to the 4th squared?
Squared.
One of those. Yeah,
2 to the 4th.
To the 2. Yes, exactly. So you have a to the m to the n. A power to a power. Sound fancy. What do we do with those exponents? Okay. We also knew from earlier, anything to the 0 power is 1. And from what I understand from what you guys learned back in, you knew something about negative exponents. What is anything to a negative exponent? If the exponent is negative, is that person happy? No, they're negative. Negative people aren't happy where they are. Where should they go? Someplace else. So if this person is negative in the numerator, where will they become positive? In the denominator. And the other way around was, if you're negative in the denominator, where will you be happy?
Numerator.
The numerator. It's like I heard from third hour, is the whole jumping back and forth between Canada. You're not happy in America? Go to Canada. You're not happy in Canada? Go to America. You'd be so proud of yourself. No, I'm messing with you. No, that is pretty funny.
Her way of saying is unhappy people go down to hell. That's what she said.
But what if they're unhappy in hell?
Then they go to heaven.
Oh yeah! All right, there you go.
I
All right.
don't say thank you to
So there's an analogy for everything, I guess.
Are you supposed to
Hey, look, a duck!
That's the whole point.
So many people love Mr.
Mr. Petrov!
Okay, I can
Martin.
picture,
Hold on, guys.
I can picture x squared.
Mhm.
X squared equals x times x.
Yes, sir.
I cannot picture x to the 0th power.
When you're looking at values, if you have x squared, that means there's two x's. Okay? You have x without a power, means it's implied that there's one. There's one of them. As you're working through exponents, as you are adding more values to it, the exponent is adding one each time. As you're going the other direction, you're taking one away. So if you're thinking of it as working up, you're multiplying, working down, you're dividing. So what would x divided by x be? 1. Because anytime you divide yourself by yourself, you're always equal to 1. So that's why when you get a 0 power, you're basically dividing it by yourself, hence you get 1.
I guess the disconnect that I'm experiencing is that 0 usually means nothing.
Correct.
So I see x to the 0th power,
Yeah.
I always think it should be 0. But
It's-
here, it actually means 0 is 1.
It's one of those things. It's one of those weird rules that is so hard to visualize what God's name is going on. But the more, and that's why I went with those the two values. As you go through, if you go through them, the easiest way to just to get, without getting into the whole nasty answer of why it works, the easiest way is to keep showing numerical of why it goes. As you go to the pattern, as you start with 2 cubed, 2, 2, 2, you get 8, divided by 2, 4 divided by 2, divided by 2, divided by 2, divided by 2. You're dividing by the base each time you're going downward, or you're multiplying by the base each time you're going upward. Does that make more sense? Yeah. There's a huge proof as to why it works, and it's horrible, and I don't even understand the words of it. But all I know is if I show people that, if you divide going down, multiply going up, somewhere in the middle you're going to cross and get 1. It's just one of those weird things. It's like subtract, multiplying two negatives together always become positive because of the way things cancel themselves out. Who knew?
That's not how it works.
Or no, in the real world we have imaginary numbers to worry about. Okay. All right. Now, what about this? When you have, let's see if you remember this. Why?
Oh, wait. Just like the same way that when you add or when you take away, it's like multiply or division. When you divide or multiply, then it's adding.
It's x to the 3rd.
You're very good. You have 7 x's up top, and you have 4 of them down here. What you're doing is you're grouping out pairs of 1. Since it's multiplying, you can simplify out by pairs of 1 each time. Therefore, you're getting 3 left. What about this, though?
X to the negative.
Good. Now, you're right. There is a flip thing that's going on here. What happens here is that I've never liked the wording on the rule for when you're dividing. What I like to do is say this. Play War. You ever play the card game War? You know what I'm talking about?
Yeah.
High card wins. Which one's bigger, a 5 or a 2? 5. Where do the X's stay then? On the bottom.
Oh, that's what Mr. Lucas said.
What do you put in the numerator then?
1.
That's what you're going to forget. You guys are going to forget to put the 1 back in the numerator.
Wait, is that a 3 or?
It is a 3. This one?
Is it negative? Oh, because you're taking away the 2.
We're keeping all exponents when we're done to be positive. Because we're happy people. We like things.
Well, sometimes.
Okay. You play the game of war, because you're right. When you said, Shimki, that it could be a negative number, you take 2 minus 5, you get -3, then you have to invert it again. It's just quicker to think about the whole idea of playing war.
So you just do the exponent, the denominator's exponent minus the numerator's exponent and put it in the denominator.
That's it.
Okay,
Play war.
sounds good.
Yes. All right. There's 2 other ones real quick to look at then.
It's 2 to the second and then 3 to the second.
What this is, obviously, if you go through the whole gamut of the real rule here,
But don't put this number first.
it does, and I'm showing you what happens here. You get 6 squared, which is 36, but in essence, what you're doing is you're distributing that negative to both parts within the parentheses. You're not foiling anything out because it's multiplying, so you don't have to worry about doing any of that. You're just distributing that power to both. It's another way of writing it, because not always are we dealing with numbers. We're going to deal with a lot of variables and stuff like that. So you'd wind up with 2 squared, 3 squared, which is 4 times 9, which is also 36. Yeah. But you know me, and I'm not going to give you all numbers. That's too easy. Because there's a button on your calculator. You can put that in your calculator and be done. What fun is that?
But you're teaching us to do it in our head.
Yes, sir. I'll try to do that too. So let me write out all the rules that we're looking at then. Well, wait, I'll just go back.
Mr. Murphy?
Yes, sir.
Are we going to be going back to quadratics and stuff then?
We do a little bit of polynomial quadrat. We will work with quadratics again and polynomials. We will do some next week on Tuesday. We're going to go back to some simple factoring, but we're going to do some factoring of higher degree polynomials that you've done via like GCFs and things like that.
Yeah, so like x plus 6 or like x.
No,
minus
we'll look at
6
something where
or something like that.
we're going to look at something where it'll be like 3x cubed plus 4x squared plus 6x, and you'll factor that.
Okay.
Yes, ma'am.
Are we gonna have word problems on the final
Yes, ma'am.
about this?
I don't know about this. These are it's tough to come up with a word problem for this. So let me go through the last one. We had what? It was a to the m over a to the n. Just remember, play war. Distributive property. Do you think that distributive property works also if it's a fraction? Yeah. No, you know what? You got all that stuff. Let me move this up for you. B is just some other number. Any other number. And it works the same way if it was A over B.
So an over an equals
AM.
Is that the same equation? An over an equals ab to the n power.
This one here?
Those are
They're
different
separate,
scenarios.
Yeah, these are all separate. Sorry, this is one. This is one. Sorry, I should have known. I didn't think to number them. I didn't think to number them.
Mr. Murphy. Nobody likes you.
That was so mean.
Have we met?
I don't know. Hello, I'm Chris. How are you?
Fine, thanks. So, Dutch banker. Guten Tag. Did the Dutch speak German? I was best think I could tell, but German.
Much better.
Yeah, work. So anyway, with all that fiddle faddle, that's good stuff. You ever had fiddle faddle?
No.
Crunch and munch?
No.
Well,
French fries?
Wow.
Look at us like we're weird. We're the weird.
yeah.
Like I said, have we met? So what I want you guys to do, oops, look at this to work. I want you to do these 6. Okay? I want you to take a few minutes and do those 6. Use your exponent rules and go through them. I want to be done with this. X cubed times x squared. Y over 2 quantity cubed.
Why does third over 8?
Whoa.
Why the third
Oh,
over
wow.
Yeah. Y cubed over 8 because it couldn't get away from the buffet.
I did 6. I did 2 times.
Oh, is y over 2?
Y cubed over 8 because it couldn't get away from the buffet.
You made that
Cha-dum,
joke last
cha.
year.
another 8. It's me, Gordo.
That was spontaneous.
5x to the third.
What?
Over 2y squared.
All
right.
right.
Numbers first. Whenever you have numbers, take care of them first. 5 and 2 can't simplify. Stays 5/2. I'm going to suggest that when you're doing these problems these first few times, to write out the intermediate steps that you're working on. Because I know you guys will screw up. Take an extra second to rewrite the problem with all positive exponents prior to simplifying. What I mean is, this x to the -1, not happy. Move them up and then put them next to the other stuff. Okay? Take the extra second to do that. You will be less likely to mess up. Trust me, I'm a doctor.
That's illegal for impersonating a doctor.
I'm pretty sure.
So you get x cubed over
y squared.
y squared.
Dr. Dre can do it, social
Okay? And now we check the other 3. 2y cubed over y to the 5th becomes
2 over y.
2 over y squared. Very good.
Why is it like everything else? 2 something.
2, yeah, you can say y to the 2nd. Whatever, it's fine. As long as it's written like that, I'm happy. The next one, you have the quantity 4x cubed, which means everything inside the parentheses, not cubed, sorry, to the 4th. So you have 4 to the 4th, and x to the 12th, which is 256, x to the 12th.
I gotta know what to do 4 to the 4.
Well, break it down. 4 squared is what? 4 squared is what? So, or basically 16 squared. Exponents, yay. Last but not least, we wind up with, let's see. We have -3 over 9 becomes?
-1/3.
Good. -1/3. X over x cubed.
1 over x.
X squared goes here. And now I'm going to bring that y to the 4th up. And what does my numerator become?
-5 y. Negative y.
Good. Do you have to put the 1 in there? Can you just write it as negative?
Just negative.
You can leave it with the -1 in there and put the y to the 5th after it. It's fine. Either one is going to be okay. So you wind up with -1y to the 5th over 3x squared. You went all goofy-eyed. What would happen?
I subtracted.
Ah.
I ended up with
He
y
copied
to
my
the
answer
4th.
and it was wrong. That's
No.
Remember, they're not happy. Ship them. Yep.
Wait, Mr. Murphy, you said it was okay if I took out the 1. I would just say negative.
Yeah, you can just say this is the same thing as -y to the 5th over 3x squared. Usually I leave the 1 in there just because that way I know that it was negative. It just forces me to remember to put it in. That's all. Let me give you some of these for the weekend.
Thanks.
You're welcome.
God.
This is on page 326.
326?
I think it's 326. I think that's what Eric put online.
Are these your drawings?
Yeah, 326. I want you to do 32 to 47.
Steven.
We have about 15 minutes
What
right now.
page is it?
You're going to get 2/3 of this done.
Right now?
236.
Wait,
All of them?
32
No,
to
that is
47.
Mr. Murphy, that's
326. 326, excuse me. 326.
32 to 47.
This is section 6.1.
Gosh! It's running away.
If you forgot those exponent rules, the exponent rules themselves are written out in long form a couple pages prior to that. We'll go over these on Mondays. We were missing a lot of people third hour, so we'll spend a little bit more time on it, which means you guys will probably fly through the stuff we do on Monday.
Already got 32.
Tuesday, what we're going to start doing is we're going to start talking about end behavior, which means we're going to look at the leading term coefficients and degrees and be able to plot graphs. Good times. Yes, sir.
I honestly thought you said math.
Said math. It had no real roots.
Wait, so what class do you go to?
Ow.
College preparation, but most of it wasn't actually.
Oh, I never picked up this.